Actually. Okay, I just want to introduce a little bit of lesson 5.4. We're not going to get very far in it, but it'll just, make it easier to get all the way through it tomorrow. So lesson 5.4 brings more identities. Okay, we've got 3 new sets of identities to add to our list, to add to our repertoire there. Okay, and I did tell you guys, you get to use a list of identities come test time, right?
Good.
So I have a page of identities I'll give you. Here's all the 5.1 identities, the 5.4. There's our 5.3 stuff we just did. 5.5 and 5.6 are down here. So it's not about memorizing these. It's about being familiar with them, knowing how to use them, all of that. So we've got 3 new ones today. We've got our double angle identities. So when we talk about double angle identities, that did not get erased from this. Really? Wow. Okay, when we talk about double angle identities, they're double angle identities because they have a 2 in them. Sine of 2u, cosine of 2u, tangent of 2u. And so it's, okay, what is that equivalent to? What can I replace it with if I don't want it to be a double angle anymore? You've got one for sine, you've got one for tangent, and notice there are 3 different options for cosine. So cosine of 2u could equal any of those depending on your situation. Okay, so those are our double angle identities. We also have power reducing identities. Power reducing, the idea here is if you have a squared and you don't want the squared, so you don't want any power higher than 1, and that's what you're sometimes asked is, okay, get it so we don't have a power higher than 1. And so they can be rewritten like this. As they're rewritten in these other forms, you'll notice, okay, it kind of brings in a double angle, doesn't it? Over here with your double angle identities, those often have a power of 2 in them. So, it's a give and take, but those are your power reducing. And we have half angle identities. These are half angle identities because they're halves. U over 2, U over 2, U over 2. You will notice the sine and cosine are plus or minus a square root. That plus or minus will be decided when you're in the middle of a problem and you look and see what quadrant you're in as to whether or not it's a positive or a negative. So we're going to work a little bit with all of these. I'm going to start into question 1. We're probably going to get rudely stopped in the middle, but we can do what we can of it, and who knows, maybe we will get through it. We can pick up tomorrow, okay? So, excuse me. Question 1. If sine of theta is 4/5, cosine of theta is less than 0, find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So basically, this problem is asking us to try out our double angle identities, right? Because they want us to find sine of 2 theta. Well, we're going to have to use our double angle identity. As you look at these double angle identities, we're given sine, but that's all we were given. We're also going to have to know cosine, and we're going to have to know tangent. Okay, so think back to previous skills. If we know sine, and we know that cosine is less than 0, how can I find information so I can find cosine and tangent? This is kind of the pre-work to get started on this problem.
Can you ask that question again?
Okay. How, if I know that sine is 4/5 and cosine is less than 0, which cosine less than 0 is telling me what?
Negative.
Cosine's negative. I need information. I want to know what is cosine and what is tangent. How do we use this given information?
What quadrant?
Okay, so we have to talk about quadrant here. So as we talk about quadrant, there's your quadrant reminder, yes? What quadrant is this problem going to be in?
Either. Oh.
If sine is positive, that puts me in 1 or 2, but if cosine is negative, that puts me in quadrant 2, yes? So what do I need to draw in quadrant 2?
A line or
An angle or a triangle?
Oh.
So we're drawing a triangle to find those other missing sides.
Attention students, if you are missing a teal and white pencil bag, it was left in the lunchroom and is now in high school office. Again, if you are missing a teal and white pencil bag, it was left in the lunchroom, it is in the high school office. Thank you.
That didn't seem like a very important announcement.
Is it pencil bag or
Pencil bag.
I couldn't figure out what kind of bags you were saying at first. I was
teal and
confused.
white duffel bag that you left in lunchroom? It's
Okay, so we decided this triangle is in quadrant, or this angle is in quadrant 2. So I'm going to draw my angle in quadrant 2. Remember, when you draw the angle, the theta we're talking about is at the origin on the x-axis, right? And then we can use this to create a triangle. Does this ring some bells?
So good.
I feel like you're resisting, but it rings some bells, yes? I agree with Carly. We need to talk about SOHCAHTOA. If sine is 4/5, what's that tell me?
4 is the opposite.
4 is?
5 is the hypotenuse.
4 is opposite, 5 is hypotenuse. If 4 is opposite and 5 is hypotenuse, what about that adjacent side? Okay, Pythagorean theorem. So x squared plus 4 squared equals 5 squared. I'm not writing this down, sorry. So x squared plus 16 equals 25. X squared equals 9, so x is 3. Now, what about that 3? Why is it negative? Yeah, we're going left on the x-axis there, yes? The sign, we went up 4, so the 4 is positive. Hypotenuse, radius, that's always positive 5. But we're going left here. So that 3 is negative. Now, with that in mind, let's see. We were already provided sine of theta to be 4/5. I'm just writing it down so I have all my information gathered. What about cosine of theta? What was it?
-3/5.
Negative 3/5. Because we're talking adjacent over hypotenuse. What about tangent of theta?
4 over negative.
4 over negative 3, so I'm going to say negative 4/3. Okay. In my opinion, that's the pre-work. Okay, so this is the information. Now, we're being asked to find sine of 2 theta. We have an identity here, yes? What's our identity for sine of 2 theta? 2 sine theta, cosine theta. That's the identity from up above. And I guess it's probably late for me to say this, but I'm kind of squishing this in because I still have 2 more to do after this, right? FYI. Because I still have cosine of 2 theta and tangent of 2 theta, so,
I do not.
well, go up above then or something. And this is a very squished set of notes, I will tell you in advance. I squish a lot in. Okay, so sine of 2 theta is 2 sine theta cosine theta. 2 is 2. What's sine theta? 4/5 times what's cosine theta? Negative 3/5. Do some math. Two times 4/5 times negative 3/5. What did you say? For the fraction part, yes. That's why I was trying to debate what you did there.
Oh, I only did one part.
Okay. So the fractions, multiply those, are negative 12 over 25. If you multiply in the 2, that's 2 over 1. So that's going to make this negative 24 over 25. There is your sine 2 theta. Next, you'll do cosine 2 theta. You have an identity, yes?
Mm-hmm.
You technically have 3 identities. Officially, pick one.
Just do the easiest one.
Which one's easiest?
And I don't know what I would even say the easiest is. Honestly, the fact that there's fractions involved, if I do one of the ones, I'm going to be doing 1, and I'm going to have to add or subtract a fraction there. So it's just going to go fractions. I usually use the cosine squared minus sine squared on this one. So cosine squared theta minus sine squared theta. And I'm going to say, you finish that, and I'll start with this tomorrow because I'm going to get rudely interrupted. So I'm going to stop right there. You come up with your answer, and we'll talk tomorrow. And remind me this is where I'm at if I forget.